Right, so let's go ahead and do some more of this homework on refutation trees that only involves the first four rules we've talked about. So that's the conjunction rule, the disjunction rule, the negated disjunction, and the negated conjunction. I'm going to go ahead and do this in freehand, so it's not going to be really pretty, but it'll be more like what yours looks like, although some of you are going to have much better handwriting than me, and it won't take me quite as long. So, okay, so we've got an argument. It's not the case that P and S and T, gotta choose me a color here, and a thickness. Okay, so it's not the case that P and S and T. It's not the case that not P or not S. Therefore, T or Q. I've lined them up here already. So what do we have to do to the conclusion? Well, we have to negate it. Is that good? Hopefully you're screaming out at me, no, that's not good, dude. That's just negating the T. You need to go put the brackets back on. And we get it's not the case that T or Q. Okay, so then we look for non-branching formulas to do first. And you can only look for those if you know the rules. And so hopefully you know now that negated disjunction are non-branching, so you got two of them. You can take your pick and go ahead and do the conclusion, and by the rule, not T, not Q, right? Not T, not Q. And what do we have to do then? Well, we have to dispatch. Always do the dispatching after you've decomposed the rule, and always put the check mark on the left. I guarantee you that if you put it on the right, I'll just mark your problem wrong because you're not paying attention to standardized form. Okay, so make sure you're doing this right. Breaking form will get penalized more than some sort of small mistake in your calculations. Okay, so not T and not Q. And then we go to the next one. The next branching rule is right here. So, right, we're going to negate the P. So negating the P means going to not P. You know, you might think, well, not P is P, so why can't we just do that? Well, the answer is the rule doesn't permit you. It's always the answer, really. So, and then we go to not S, and that's the full decomposition of that formula. Look and check for contradictions. Do we have any more that are non-branching? Well, the answer is yes, because now these two, the double negations, are non-branching. So now we can go ahead and go P and S, right? Check, check. Okay, so then we have one last formula to operate on, and that's going to be a branching rule. So that goes to, so anytime we draw a branch that's saying or, right? So now we've got, it's not the case that P and S, or it's not the case that T. Okay, now what's interesting here is everything up here has now been operated on that can be operated on. You can't operate, there's no rules for negated atomic formulas or not negated atomic formulas. So this branch has nowhere else to go. And so if there's no contradiction along this line of the branch, right, if there's no contradiction here, then that is a counterexample. That's an interpretation where you have true premises and a false conclusion. There is no contradiction. So you would just go ahead and write open branch, invalid. Now, if you wanted to go ahead and operate on here just for the heck of it, you can certainly do that. So this is a branching, it's a negation conjunction. So not P or not S. And interestingly, you do have contradictions here, right? So you travel up, not P, S, P, right? Not P and not P contradict each other, so that closes. Not S contradicts S, so that closes. But it doesn't matter that these close because this one is open and you only need one open branch, right? Okay, so let's go to the next one. So we're going to go ahead and negate the Q. Okay, so negating the Q means putting the negation on the outside, and then we go ahead and just operate on it and just take it to Q immediately. Right? So not Q, Q. Then we have an OR, a bona fide OR, and a conjunction. So conjunction just goes to S, T, dispatch, and QST, right? No contradiction so far. So let's operate on our disjunction, and we got it's not the case that P or Q, or it's not the case that P or S, right? So this is and so still no contradiction. This is a negated disjunction. So we go, it's not the case that P and it's not the case that Q. Dispatch. Ooh, no, see, I screwed up. I did not dispatch that. See, that's how easy that is to do. So go back and make sure you do that. Hopefully you caught me when I did that. It's not the case that P or Q goes to not P and not Q. You can see that not Q here contradicts Q up here, right? Just go right up. Q, not Q. So you got closure there. And then you've got not P and not S. And not S contradicts S. Closure here. So this one, all branches close, valid, right? All branches close. All right? Getting the hang of it? I hope so. If you're not getting the hang of it, the number one problem is not knowing the rules. After that, it's not being able to detect the main operator, and the rules don't help you if you can't do that. So you would need to go back and review that kind of stuff. Okay, so what the heck is this? That's not right. Okay, let's fix that. All right, that's more better. Okay, so it's not the case that T or R or S. That's a disjunction, right? It's not the case that S or not Q and R. That's a disjunction. And T or not Q, that's a disjunction. So here we have potentially a bunch of branching going on, unless we're lucky and it closes very early. Okay, so in other words, everyone's a branching formula, right? Oh, actually, no, right? Because here, look, jumping the gun. Okay, all I did was line them up, but I haven't negated it yet. So we're going to go ahead and negate. So not T or not Q, right? So this is non-branching, so this goes to not T and not Q, right? You got to negate the not. So not Q, dispatcheroonie, and not Q. Okay, not T, not Q, And then we'll go ahead and just go. This is a good thing is when you get the double negated formulas, just go ahead and apply double negation right away. So not Q, that's kind of ugly. It's a bad Q. Go ahead and do that, make that a little bit better. Okay. Good. All right, now we got two branching formulas. And so you can take your pick here. Sometimes you can kind of see that something's going to give you a quick contradiction, at least on one branch, but in this case, that is not the case. So we'll go ahead and just do the top one, give ourselves a bunch of room here because we can foresee quite a bit of branching. And so then you just got, it's not the case that T or R, not the case that T or R, or S, and dispatch. Okay? Now, you've got a non-branching formula here, so a good idea to go ahead and just take care of that. So we got not T and not R, dispatch. Notice how this, right, you do not write not T, not R. You don't decompose this formula under this, right? Why is that? Well, because this formula here, S, is not under this formula, right? You just keep going down, 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 down. Okay, so it's not the case that T or R, not T, not R, check. And then the last formula we have to operate on is it's not the case that S or not Q and R. And you've got to put this under here and here because these formulas here on the left and the right are under this formula. So you have a branch, and when you decompose a formula, you have to take it all the way through. Don't just stop halfway, even because you see some kind of non-contradiction. You got to, if you check this off, that means that you decompose that formula the whole way, right? So, all right, so go ahead and operate on this last formula, which is a disjunction. So we've got not S or not Q and R. Notice I dropped the brackets here. You don't have to, but the brackets had to be here, up here, but now that it's a formula on its own, I can, it's not a sub-formula anymore. I can drop the brackets if I want to. And again, not S, not Q, and R. Remember, anytime you are asking, well, why is he doing that? Well, the answer is that's the rule. So you got to go back and look at that rule, internalize it. Great. So not S. What did we not do? We didn't dispatch because I started jabbering. So not S. Does that contradict anything? Is there any contradiction here that we missed? Not T, Q, not T, not R, S. No contradiction, right? No contradiction means this is open, branch, invalid. Already invalid, okay? And if we wanted to look further, we can see that not S here does close, and if we wanted to go ahead and complete the tree, which you don't have to, unless I told you do the complete tree, which is like telling somebody to do the complete truth table. I'd go not Q and R, dispatch, right? And R contradicts not R, and not Q and R, dispatch, and here not Q contradicts Q, so that closes. So really this one here is the only open branch, and it's the only one that makes it invalid, right? Okay, let's do the last one in this set. Quite a lot of formulas here. 3 premises. Okay. Not, R or not S and T, L or M. L or, it's not the case that R and T, which we need to negate, like that, not, right, like that. Okay. So, should have been saying this all along, but of course you should be trying these before I do them. If you're just watching me do them, you're learning almost nothing. This is something that requires you to do this sort of thing. Each step of the way should be stopping. Okay, what can I do next? But don't just watch it come out of me, unless you just find it entertaining, because it's not a learning event when you do that. One of the most common things to be told, for a teacher to be told, if you're ever telling this to a teacher, they're going, oh, okay, yeah, I've heard this 1,000 times, is I understand it while you're doing it, but then I can't do it. But the truth is you don't understand it while I'm doing it if you can't do it afterwards. It's just sort of making sense to you. But understanding it while I'm doing it is the same thing as saying, oh, exactly, that's exactly what I would have done. All right, enough of the lecture. So what we've got a double negation rule we can apply right here, right away. We've got an and, which is a non-brancher, and we got a negated or, which is a non-brancher. So actually this should not be too bad at all. So why don't we go ahead and do not R or not S, and that means we pry off 2 of those negations, right? So we still got 1 left. So we're going to write R or not S like that. Okay. Now that is a non-branching formula, right? So that goes to, and you don't have to do it in this manner because there's others that are non-branching too, but not R and not S, right? So not R and not S. Dispatch, no contradictions yet. S, right? Dispatch. Follow me? Because that's a double negation rule. Still no contradiction. But look, not S and T. Not S, T. Now, I dispatch that, and amazingly, I have come up with a contradiction, S and not S here, before I even operated on these 2 lines at all, which is just fine. There's no problem here. I got a contradiction before I even had to do any of the branching formulas or anything. So this is over. This is finished, closed, right? This is closed out immediately, and this is a beauty of the refutation tree rules, how fast this can be done, and therefore it's valid. Okay, so just to check our work here, not R or not S, went to not R or not S, which went to not R and not S, okay? And then R, and then not S and T went to not S and T, and so we had a contradiction right here, which allowed us to close it out. Okay, so sometimes it looks it's going to be an awful deal, and turns out that a lot of work. Turns out it's not. All right, so those were all the homework problems that were specifically about just these 4 formation rules. And in class, we'll be incorporating the rules for the conditional and doing some more of these. All right.